Hello everyone. We're going to continue our discussion of divergent headworks. So with some examples, I'll try to explain different aspects of this kind of headworks. Let's first start with the location of this kind of projects. As you can see here, the project that I've demonstrated in the previous lecture, it's close to the hilly part or the mountainous part of the terrain, and the reason behind that is that it has a significantly higher elevation in this portion, and that gives it a significantly higher, larger command area. Command area means the area which can be irrigated from this location. And if we construct the divergent headwork much lower than that, suppose somewhere around here, then we would lose the ability to command the portion in the higher elevations, that is here. We can command higher, greater amount of areas by constructing this project even higher up in the river, but that will cause some other problems. As you can see, as we move upstream, the nearby areas become more occupied by mountains. And if we construct a divergent headwork at this location, then the problem would be to carry the water to these locations, because then we'd have to cross lots of natural barriers. For example, either we'd have to cross these mountains like this, hilly areas, or we'll have to cross these kind of natural drains. As you can see, these natural drains or natural streams or small rivers or tributaries, they are much more common in the mountainous part or the hilly part than they are in the plain part. And that's why if we construct a project in the upstream regions, then although we are having a greater command area, we'll not be able to carry the water through a canal, because economically, because it will have to be crossing lots of mountains and natural drains, and that is not a very trivial task, because either you'll have to construct some tunnels, dig some tunnels through these mountains, or you'd have to make some cross drainage works. Cross drainage work means when you are transporting water across a natural stream, that means your canal will have to come from this location to this location, but in between these natural streams will have to be crossed, and that is done by lots of other structures, and therefore we generally do not prefer this kind of location. And we also do not prefer a location which is much downstream, that is in the plains region, because we will then have very small amount of command area, and this upstream areas, these areas will not be able to command. So this is a kind of optimum region where we can set up our project. There is one problem in this kind of location, is that there are lots of boulders in the river, and that causes lots of seepage through the foundation, because the bouldery state of the river is not, the riverbed is not that, is actually very porous, because it is mostly filled with large particles rather than small silt and sand particles. But we have to compromise at least somewhere. So if in this region we find some place where the amount of boulders is less and it is mostly sand and silt, then that location will be far preferable. Now I'd like to show you some pictures of this project that I visited a few years ago. So this project is called Bordikarai Irrigation Scheme, near Arunachal border. So this is a picture taken from the upstream. Here I was standing on the embankment, the guide bank. So you see the slope of the guide bank is protected with this kind of concrete blocks, and these are the undersluice gates. These undersluice gates will be, these gates are closed so that some amount of water is stored in this location. Here some other gates are open. You see these gates are raised so that water can flow through them. And up above you can see these kind of machines or motors which are connected to these gates by cables. This is one of the divide walls. This is one divide wall, and this is another divide wall. This divide wall is actually part of the fish ladder. This fish ladder is having another wall on the other side which is not visible from here, and it also has a small gate. That means the fish ladder is not always open. Only when it is needed, then the fish ladder is opened for some time. So up to this point there are some gates, and there is another additional gate in the fish ladder. The rest of the weir is ungated. As you can see, it's from this location up to this point. The weir is not having any gates, and that means whenever water is above the top of the weir, it can flow through these openings. There are no gates here. And in this particular project you can see that you cannot see the weir here. These are only the pillars that are supporting the roadway above the weir, but you cannot see any part of the weir because there is so much sedimentation on the upstream that the sediments have risen to the level of the top of the weir. The weir top or crest is at the same level as the sediments. There is a problem that occurs in most of these kind of projects. And this is the head regulator. This is constructed nearby the undersluices, and here also there are some this kind of arrangements, machine arrangements, and this is a picture from the downstream side. So you can see the downstream of these undersluice gates. So these are the divide walls. This is one, and you can see another one in a distance. And as you can see here, so I was standing on the guide bank or that embankment. This guide bank goes like this to a large distance upstream. And this is the head regulator. There is a small bridge to cross to the other side. Here you see the canal. The canal also, you can see it's not very well maintained, and there is lots of sedimentation. And as you can see, I guess on the left hand side, there is some erosion from the embankments of the canal also. So that has also filled up some portion of the canal. And these are the gates. These are the machine arrangements which are connected with cables, as you can see, and these cables run downwards and they are attached to the gates. So these gates can be raised or lowered as per necessity. Now let's look at some other aspects. I think this model is a little bit more to the scale than the previous lecture. So this is a very wide river, let's say. And this is the fish ladder. This is the weir. This is the one divide wall. Here also you can consider it a divide wall. And these under-sluice gates, they will, the number of these gates or the size of these gates will depend on the highest amount of flood that needs to be released when that flood comes. So here I've only shown 4 gates, but if the highest flood is of very large magnitude, then maybe we would have to provide some more gates here so that when flood comes, we have a larger discharge capacity so that the upstream is not flooded. Now, let's discuss some more about these undersluice, the silt excluders. See, they have a very peculiar arrangement. These are long tunnels. The tunnel very close to this head regulator through which water is transferred to the canal. That is the longest canal, and as we move away, that tunnel, as we move away from that, these tunnels become shorter and shorter. The reason behind that is when water goes into these gateways, they have a component, velocity component like this. And if we had made all these tunnels of same length, then because the velocity is happening this way, then all these tunnels water will not enter these tunnels and they will flow perpendicularly. Once we are making the tunnel, once we are adjusting the tunnel lengths so that this tunnel is the longest and this tunnel is the shortest and so on. So in that case, because the water velocity is in this direction, then a major part of the lower portion of the flow will enter these tunnels, and therefore along with that, sediments or the silt will be trapped inside these tunnels. Sometimes these tunnels may not be necessary if the natural riverbed is much below the sill level. Sill means this level, that is the threshold of this head regulator, is called the sill. If the riverbed itself is much lower, suppose 2 or 3 meters lower than this level, then these kind of silt excluders are not needed because the lower part is already much lower than the sill level. So therefore, the sediment which is carried by the lower portion of the current will not be able to enter these gateways. So these are some of the facts that I wanted to add in continuation to the previous lecture. And one more thing that I forgot to mention is that you see these cut-off walls or the sheet piles. These are provided here so that water doesn't simply flow straight from this point to the downstream end of the impervious floor. And because of provision of these kind of cutoffs, they'll have to take a longer path. They have to first go down, then up, then again horizontally, then again in this cutoff they'll have to go down, then up. So it increases the length of flow. But one problem may be that what if the water in the side of the work of this impervious floor, that is on the edges, on the right hand side and left hand side, this water can directly go from here to here, and that can be prevented by extending these cutoffs to a considerable length and inserting them into these embankments. so that when water tries to take this sideway, it also has to again go through this longer path, because there will be cut off in the horizontal direction also, and therefore the leakage will be reduced. So that's all for this one. Thank you.
So that will be discussed here. Okay. So suppose this is the river. If you have a river, in this particular slide, its direction of movement of the water, direction of flow of water is also indicated by this arrow. And we need to divert this water into a canal. So this thing is achieved by diversion headworks that you have studied. We provide the guide banks, marginal bunds, then the weir or the barrage section, divide wall, and the head regulator here. So this is the portion where we provide the head regulator and we divert the water into the canal. But it's not only one canal which is basically withdrawn directly from the river, but the water in the canals, because canals are the artificial water carrying structures, ultimately the water will be fed through the rivers only. So the canal ultimately has to start from the river. But once we have taken the water from the river and diverted it to a canal, thereafter the single canal cannot go everywhere. We need to divert the water from canal to canal also. Okay, so we need to divert the water from this canal to this canal. Okay, now further we can have some divergence from this canal to the next canal. So canal to canal diversions are all of similar nature, and the very first thing here, that is from river to canal. So the first diversion is from river to canal. Thereafter, all the diversions will be from one canal to the other canal. Okay. So the structure that we provide over here for this diversion, to assist this diversion of water from river to canal, that is called the diversion headworks. But the same purpose is required to be performed by some device here when the water will be diverted from canal to canal. But canal to canal diversion is not achieved by providing the diversion headworks. It is achieved by providing canal headworks. But diversion headworks needs to take care the vagaries of this river also. The uncertain behavior of the river also is to be taken into account, and huge quantity of water is there in the river. So the structure to be provided here, that is entirely different. So it is called the diversion head. But when the water is required to be diverted from one canal to the other, so what kind of structure we provide over here, that is called canal headworks. Okay, but during this journey of water from river to canal, then canal to canal, and then further this canal to next canal, the water takes some silt also along with this. The water takes some silt when it is diverted. So in the previous lecture, we have studied one device which was provided to prevent the entry of silt from river to canal. But entire silt cannot be filtered out. Okay, so we have to provide some structures. So what kind of structures are provided? I have categorized them into three categories basically. So where these structures are to be provided and what is the category of the structure. So let us see. So before that, I would like to make a mention over here that from this point onwards, we have provided canal to canal diversion. So the canal from where the water is to be diverted, the canal from which the water is to be diverted, that is called the parent canal. Okay, like at this point, this is the parent canal, and the canal in which the water is diverted, that is called the off-taking canal. Okay, now moving downstream side, if we need further diversion, and if you take out some other canal out of it, then of course this canal will be acting as parent canal, and the next canal to which the water is diverted, that will be termed as the off-taking canal. Okay, so now coming to the devices. So this is the location. The circle represents the location where the device will be provided, and the number indicates its category. Okay, so first type of structure that will be provided within the river. So this location is within this river only, but it is on the upstream side of this canal. So canal head regulator is provided over here. So on the upstream side of the canal head regulator, this category 1 structure will be provided. So this is provided in the river only. So second location is, this circle represents the second location, and the number 2 represents the second type of the devices. So here, same device cannot be provided over here. It is of different category, different devices there, but location is here. So where is this location? It is within the canal at the downstream of this canal head regulator. It is a little downstream side of the canal head regulator. Some structure is provided over here. And third is this location. This third location, you can see it is analogous to the first location. Here, the water was being transferred from river to canal. Here, it is being transferred from canal to canal. So it is within this parent canal, in front of, right upstream of this canal head regulator for this off-taking channel. Okay, so these three types of, three categories of the silt control devices are provided. But here also, next location I have mentioned, on the downstream side of this canal head regulator, a little downstream side, but the number mentioned is 2. That means the same structure that we provide over here can be provided over here also. Of course, the magnitude or the size of the structure will be different. Okay, so same structure can be provided over here. So 3 categories are there. So let us tabulate them. So device symbol 1, it is within this river at the upstream of the canal head regulator. Okay, it is within this river, this one, it is within the river and at the upstream of the canal head regulator. Here the canal head regulator, it is on the upstream side. So first device is to be provided and its name is silt excluder, that you have discussed in the previous lecture also. Now device symbol 2, its location is downstream of the head regulator. So here we have the head regulator and we have provided on the downstream side of the head regulator, we are providing the structure category 2. The device symbol is 2 and its name is silt ejector. Third is in parent canal. This is the parent canal. So this is within the parent canal, but on the upstream of the head regulator of off-take canal. So this is the off-take canal. Here we are going to provide the head regulator on the upstream side of the head regulator. Okay, so this is device symbol 3. So here the name of the device is either vanes, groin balls or skimming platform. There are 3 different devices. We will be discussing them all one by one in this lecture. Okay, so we can provide either vanes or groin wall or skimming platform. So So we have this category which can be provided at the point where the water is to be diverted from canal to canal. Okay, like we are providing silt excluder at this point in the river. Analogous, water is to be diverted from canal to canal.